Hi everyone. So I'm very pleased to be here and to meet the MyData community. It's kind of new for me, that community. I'm more used to software development community. I'm from Belgium, and just a quick introduction about me. I'm running Pull Review, which is an automated code review service, and I'm software engineer at Tallinn. We do a lot of things around big data for other companies, such as installing data lakes or doing a data science project. I love other stuff too, baking bread, snowboarding, and so on. So we have a lot of topics we can talk about. You can find me on Twitter, GitHub, and also my website. So recently I started to work with data lakes, using them, installing them, and so on. And because I wanted to understand better what it is, how you can control better the data, how you can take over your own data, for me the best way was to building my own data lake. And this is the little story of that experience, the kind of question I went through and the principle I decided to follow. So it started with one question: where can I put my data? I could be a neuroscientist and I need to put my data research experiment somewhere. I can be a marketeer and I want to store all my social network data and analyze them afterwards. Or maybe I'm a live quantifier and I have all those tracking data as walking, sleeping, and heart beating, and I want to crunch them, but I don't know yet what I can do with that. So very likely the volume of those data are very low, but they are very numerous, and I don't still know yet what I can do with them. So the question is still, where can I store those data, and how can I find them when I need them? So basically I need a data lake. And even though I'm not a big organization, the need is kind of the same. So the approach of doing it by myself is based on, if I can do it with a simple mechanism, I would have a better understanding what are the core functions, the needs of a data lake, how can I take over the protection of my data. By having an open source approach, I can be transparent how I take over the data. I can show to everybody the way the data will be handled. If it's light, I mean, I don't have so many data, so I don't need a very big cluster. So if I can do that very lightly, it's better. And of course, it's an experiment, so I want to push the boundaries as much as possible and see how much time, I want to develop as least as possible in order to achieve my goal. So it's a kind of critical thinking experience. So what kind of things I can do by myself? I want something light. As I said, the volume is not very important. I want to focus on the core function of a data lake. I want to have a serverless approach. I don't want to manage servers. I just want to have a service that offers me the functions I need. I mean, storing the data and retrieve them when I need them. I want at least the minimum development time. I want something with a vernacular API, something that I can request from everywhere, from any programming language. So it's very easy to integrate. And I want a straightforward protection, something not very complicated that I can understand by myself, and that I don't rely on a third-party service. So for the core functions, basically I need some ingestion, so to create the data, to store them, and I need some search to find the data when I need them based on some metadata, and then to retrieve the data that I would like. As I said, I want as much as possible a serverless approach. So I mean, try to find the third-party services that I can use in order to reduce the time of development. as I tell, the goal here is to focus on the API and the mechanism to put everything together to provide me the function I need. To have a vernacular API, so basically I opted for a REST HTTP API because it's the most common one today. And for the protection, and I will come back to that later, basically I just want something that I can handle locally. So I have the keys locally and I encrypt the data and I push them so I don't have to worry about the protection afterwards. So for the core of the data lake, mainly it's a web API. So as a web API, I need to go through the different important functions. So for the ingestions, there are several questions how I can do that. Should I do the creation and the storing together? Should I push first the metadata and then upload the data, or the opposite way? So I decided to follow two important principles. One was that the data would be identified by the metadata, so it's important to first create the data before to upload it, and then to possibly delegate the upload to a third-party service, so I don't have to deal with the load of uploading the data. So I ended with an ingestion that can be done in two steps. You have a post request where you will create the metadata and index the data, and then you have a put request that allow you to upload the data, and that could be possibly delegated to a third-party service. For the search, other questions, how can I do the search? I want to be flexible, so it could be any metadata. I want to use HTTP, so it's basically just a query. And very simple grammar for the query. So every criteria that I would pass will be used as an AND criteria. Then there are other questions like, is there any metadata that should be required or optional? So for the exercise, I decided that for the format of the data could be a required metadata, but nothing religious there. And then come also the question of efficiency. And again, for me, it's more a service question, so I delegate the question to the selection of the third-party service I will use for that. So I ended with a GET request with a query, HTTP query. So for instance, I want to retrieve all the data that are CSV file and that has the metadata year 2016. And I would obtain an array of all the data. Then finally, when I found the data that I would like, I need to retrieve them, and it's basically just a GET request. And again, I want to possibly delegate that request. So it's a web API. I want a serverless experience. I want to keep it simple. So I picked a very simple web framework. It's a Ruby framework. And basically, the main reason was I know the framework, so it's easier for me to develop with that. And also the language allow me to deploy the data lake on any platform as a service. And for the exercise, I selected Heroku. What was important here is to select a service, a provider that has some data center in Europe. So of course, even it's an American company, has some guarantee over the data. But we come back to that later again. So we talked about the way to implement the API. Now we need to take care about the metadata. How can I store the metadata? So my needs were, I want to be able to search for JSON. So I will use JSON as a document to store the metadata. Basically, so I need a document-based storage. If possible, I would like also to add some structured fields, but it's not required. To have an easy integration with the provider, I selected to deploy my API that is common and possibly that has a free tier. I selected PostgreSQL. It's very common. It has a native support of JSON, and you can extend it easily, and it scales quite well for my use case. Then comes the question to store the data. So which kind of service I can use? I need basically a blob storage with a REST API. If it has European data center for the same reason for the metadata, it's better. If it's compatible with S3, it's better because it's quite common as an API that has a simple authorization system, so I can delegate the upload and download. And after some configuration, I selected the Amazon solution. What's interesting here is that you have get input request in the REST API F3 that you can pre-sign. It means that you can create an URL for your object, and that URL will exist for a certain period, and then it will expire. So it's an easy way to give authorization to access that object. So MyData Lake then can create that pre-signed URL, give it to you, and then you can use it to download or upload your object. And so by using the HTTP redirection, the 307, you can tell the client to replay the request to the third-party service. So it's very transparent to the client. So it's an easy way to delegate the request to a third-party service, and you won't see anything. And finally, where was the question of protection? So I will send some queries. How can I protect them? If I use HTTPS, I have a reasonable protection of my queries. If the metadata are not very critical, that's enough. And of course, those metadata would be stored in a PostgreSQL database. So if it's not so critical, I don't need more encryption. And if those data and metadata are in a European data center, I have some low guarantee over those data. Then comes the question about the data that are more critical. How can I protect them? And so for me, the easiest way was, okay, I don't need to handle the data directly. Anyway, I'm the only one to use them. So if I have the keys locally, that's okay. I can encrypt them, push them on the data lake, and I mean the data lake is just there for the storage and to retrieve the data when I need them. So if I can handle the protection locally, then I make it simpler to protect the data. So by using a simple SSL encryption locally, I have the key, I encrypt my data, I push them on the data lake, and when I need them, I retrieve, I decrypt them, and I can analyze the data that I retrieved. And normally there's a little demo because some technical problem, which I can show that afterwards, but basically you find the code for the experiment on two repositories on GitHub. One is Oasis, it's the data lake itself, and the second one is Sigua. It's a Python client that allows you to retrieve easily and to interact easily with data lake. So you can search the data, you can retrieve them, you can upload and download them. That's it.